volume at the end. If you wanted to be really an asshole about it, you'd say your units are wrong, but I mean the math doesn't care. I'm still going to get the area. And here's the funny thing about this problem. How would you do this in 2D? I mean, this is really a two-dimensional problem, right? I want the area bounded by y equals x squared and y equals, where'd it go? 1, yeah. Cool. So maybe I can make my things all match up. That'd be great. So here's the problem here. I want this area there, right? Now in 2D, what would you do? To get the area in between those two, how do you do that in general?
It's 1 minus x squared.
I like it. So it'll be an integral of the top function minus the bottom function.
It's from -1 to 1.
From -1 to 1. I love it. Now, if you want to use a double integral, you do this trick where you get the right number. Somebody can gripe about the units, but I don't care. I just put the right units on there. Leave me alone, right? What I do is I integrate the constant function z equals 1. That'll be like this top 1 unit up from the xy plane. So in this case, I'm going to have a circle in the xy plane, integrate the function 1, and then I'll get the area of the circle, which, you know, is kind of like overkill, big time. But some areas are very difficult to get directly. So double integrating might actually help. If you look at the double integral they end up with, so it's got to be the one that's got a 1 inside. So it's got to be a or b. And of course, b's limits don't work, I don't think. Yeah, b's limits have a y squared in it, which is neat. So it's got to be a, and a says this. And when you take the first step, what do you get? Integrate this piece here.
Just 1.
You get 1, and when you plug in the limits, you get x. Sorry, y. When you plug in the limits, you get 1 minus x squared, which is, of course, the same stupid thing we do in 2D, right? Okay, so in general, that's the process of finding the area of something that actually just sits in the xy plane, or in 2D. I just put a 1 inside and integrate that. I'm going to get the right number. I would just get the area of the base here. The units I don't care about, because I got to slap those on anyway. So I'm just going to slap the right units on. Okay. So if you integrate a function of 1, you end up with the area of that region you're integrating over. That's kind of a nifty result. Okay. If you think about it hard enough, it makes sense. That's all we're doing right here is this. The number's going to be the same as the area of the base, because we just multiply by 1 to get the volume. Same idea. Exactly same idea. What about, where am I at, 5? So I got a somebody said A.
Got C.
So I got C.
For which one?
For number 5.
I got C.
Split. Dude. So I see here, it starts off 0 to 1, x squared to x to the 1/3, f by dx. Right, yeah, good. So if you draw this region, what does it come out to be? X can go from 0 to 1. Y has got to go in between x squared and x to the 1/3. Right, and for values in between 0 and 1, the higher the power, the smaller the output. So sure enough, x to the 1/3 is above x squared. Because we all know between 0 and 1, it's x squared is like this, and x to the 1/3 is with root. It goes like that. So we get one of these little fish dudes. Remember these? Shoop. Shoop. Right, where they meet at the ends like that. So this one is the 1/3. Or x equals y cubed, good. And the other side is y equals x squared, or x equals square root of y, because I know I want the positive one. Okay. Snap. So now, so the way it's written, as x goes from 0 to 1, y goes from x squared to x to the 1/3. Right? And I remember doing this as a student. I just loved to draw these and then do those little arrows for myself. So I was like, okay, I can see it happening, the limit. It goes from this function to that function. Cool. Now turn that bad boy around. Draw the arrow the other direction. So now as y goes from, right, turn this around, as y goes from 0 to 1, and I know that just because I knew that they met back at 1, right? I mean, remember when you had to set each function equal to each other to see where they actually meet? So you can see the endpoints that you have to use. We have to do that in 3 dimensions also. I'm sure we're going to do one like that in a minute. So as y goes from 0 to 1, x does what? It goes from this to this, doesn't it? You can see that now, right? So x goes from, yep, exactly. X goes from y cubed to square root of y. F blah 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 blah. Do you guys see that? I mean, it's really difficult sometimes to do it without drawing that picture. It's really easy to forget which one is where in relation to the other one. If you draw it, it's very simple. You go from there to there. That's what x does. So it's got to be from this dude to this dude. There you go. Okay, all right. Okay. What about number 6? All right, so we got some controversy there too. So 6 starts off like this here. So as y goes from 0 to 1, x goes from negative root y to root y. And of course, if x equals root y, y equals x squared, and it's picking up both sides of that thing, so it's going to be whoop, whoop. So as y goes from 0 to 1, x goes from this to that. Now just turn it around again. So I'm going to end up with this here, right? So what am I doing if I do it the other way around? If I do it the other way around, what does x do?
Negative 1 to 1.
As x goes from negative 1 to 1.
Y goes from x to 1.
Yeah, so if I pick an x, pick this x here, what's y doing? It's going from this to this. So it's going from x squared to 1. And that would be, yes, b. All right. But do you guys start to see what you have to do here? It's really not that difficult once you see how to look at it. It's kind of, I remember this, I loved this stuff. For some reason, first one. What about number 7? They finally give you one you actually have to calculate the full thing out. How'd this go? Did this go all right? Why would you probably not want to switch the limits of integration here? Because
X is constant, so it's
Because natural, then you have natural law.
you have natural log stuff in there that you carry through it. It might not make it that difficult, but I want to do natural logs before I have to. So I can try to tag it the way it is. So how this go? The inner one? Yeah, you get y squared over x, and you've got to evaluate that from 0 to square root of x.
So it's 1.
Yeah, so I get integral 0 to 1. Square root of x goes in, becomes x. I get 1. The thing to be careful about is, no, that's fine. Square root of x is 1. And of course there you get 1. That's fascinating. Integral of 1 is x. Plug a 1 in, you get 1. Wow. Amazing. Okay. So let's do this. Let's I want to see if you guys can,
Did this before.
let's take like a 10-minute break. Come back 10 till 2. And then we'll do 13.3 and we'll do a good chunk of 13.4.
The quiz is on Monday, right?
No quiz actually, we don't have time for
Just
quiz.
going to the test straight on Wednesday.
Monday will be review day for the test.
Sounds good. When?